Today's lesson, we're going to add a few more theorems that have to do with angle-pair relationships. This first one is so obvious that it seems like it could be a postulate. Right angles congruence theorem says that all right angles are congruent to each other. The only reason they call that a theorem, not a postulate, is because it can be proven. Let me show you how you will be using this in your proofs. Let's say that you knew that angle 1 and 2 are right angles, and that was given to you. What would we write using the reason of right angles congruence theorem? We would just be able to easily say that angle 1 must be congruent to angle 2. So that's what that theorem is helpful to say, that if you have right angles, then those angles are congruent to each other. The next one is the linear pair postulate. This one is used a lot. Anytime you see a picture of a linear pair, you can say that if two angles form a linear pair, then they are supplementary. So what does the linear pair postulate tell us about that picture up there? We could say that angle 1 and angle 2 are supplementary. If we wanted to set up an equation saying that those add up to 180, then we would have to use the definition of supplementary angles. So now that we have shown that those have to be supplementary, now we could say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. But that was using the definition of what supplementary means. Remember, in the linear pair postulate, you go from a linear pair to the word supplementary. The vertical angles congruence theorem. We've been just sort of assuming the vertical angles are congruent for a long time, but here it is in theorem form. It can be proven, and you'll get to see a proof of it later, but the vertical angles theorem just tells us that if you see vertical angles, then they must be congruent. So we can see vertical angles just given in a diagram. In this diagram, angle 1 and angle 3 are vertical angles. So what would we say using the vertical angles congruence theorem? It just allows us to write that angle 1 is congruent to angle 3. I think these two theorems sound a little bit confusing. It's the first one, congruent supplements theorem. If two angles are supplementary to the same angle or to congruent angles, then they are congruent. So the two angles they're talking about here, if I use the picture, are angles 1 and 3. If we have two angles that are supplementary to the same angle, so let's say that both of those are supplementary to angle 2. Well, if angle 2 is 140, that must mean that angle 1 is 40 to get those to add up to 180. And then if angle 3 is supplementary to angle 2, it has to also be 40. So again, what that theorem is saying is if those two angles are supplementary to the same angle, then those two angles must be congruent. That's the only way it would work. Same idea works for complementary angles. This time the two angles we're looking at are angle 4 and angle 6 here. Let's say that angle 5 was a 50-degree angle, and we knew that angle 4 and 5 were complementary. That would make this guy a 40. And if we knew that 6 and 5 were complementary, that would make this one a 40. And so if those two angles are both complementary to that same angle, then those two angles are congruent to each other. That is called the congruent complements theorem. Let's look at an example that uses some of these. So here we've got given angle 1 is supplementary to angle 2. The next part is the linear pair postulate. So when it says linear pair postulate, you should always look up at the diagram and see if you can find yourself a linear pair. And that would be those two angles, angles 2 and 3. And do you remember what the linear pair postulate allows us to say about angles 2 and 3? It says that they are supplementary. So we could say that angle 3 and angle 2 are supplementary, or putting that another way, angle 3 is supplementary to angle 2. So again, the linear pair postulate allows us to use the word supplementary. It's time for some congruent supplements theorem. The congruent supplements theorem says that if you have two different angles that are supplementary to the same angle, That's what we have going on here, right? If you have two different angles that are supplementary to the same angle, then those angles must be congruent. So that's where the word congruent comes from in that theorem name. If they're supplementary to the same angle, then they are congruent to one another. And it looks like what we were trying to prove is pretty close to that. Always the thing we're trying to prove goes in the final box. And how can we make that leap that if the angles are congruent, then their measures are equal? That is what congruent means. So that's the definition of congruent angles this time. How would you like to knock off number 1 off your worksheet today? Let's kind of work on this together. We're going to prove the congruent supplements theorem. The theorem says if two angles are supplementary to the same angle, or to congruent angles, then they are congruent. Let's remember that the if is the given, and the then is the conclusion, so that's what we're trying to prove is true. So the way they have this set up is they have two angles supplementary to the same angle. You see this? We have angle 1 supplementary to angle 2, and we have angle 3 supplementary to angle 2. And so those are just the givens. That was the if part of the theorem. How do we know that angle 1 and angle 2 add up to 180 degrees? Well, it was because it was given they were supplementary. So that's the definition of supplementary angles. How did we know that angle 2 and 3 added up to 180? Again, we knew that 2 and 3 were supplementary. So again, the definition of supplementary. And we had that vocab word in our givens. 2 vocab words, and so we wound up using the definition of supplementary twice. What's happening now here? See how that equation switches? Switches sides, symmetric. All right, this one might be a little tough. How did they know that 1 plus 2 equals 2 plus 3? Well, I know that 1 plus 2 equals 180, and I know that 180 equals 2 plus 3. Do you see the train? 1 plus 2 hooks up to 180. 180 hooks up to 2 plus 3. So 1 plus 2 hooks up to 2 plus 3. I was going to go transitive property on that one. And since that was an equality one, I can see making a case for substitution on that line as well. Some people find this next step a little tricky. How did they make it from that equation to this equation? Do you see what's different? The angle 2's are missing. Where did the angle 2's go? It's not a transitive because I don't see equals signs in here. What it was an algebra thing. If you have an angle 2 on both sides, you can subtract the angle 2 off of both sides of the equation. And finally, this old step, once we know that the angle measures are equal, we can say that the angles are congruent to one another, because that's what congruent means. That's the definition of congruent angles.